Hello, I am Shane Brinkman-Davis-Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. Today we're going to revisit a presentation I did many years ago that has to do with mastery, specifically the path of software mastery. The way I think about mastery is you've gone far enough down a discipline to discover what the path looks like. And mastery is that point where you realize that there is no end to this path. You know where it's going, but you have no idea where it's going to end. And you can see that there is an infinite amount of improvement that can be made along that path. So join me and we will dive into this presentation about how do you become a master software developer. So, the path of software mastery. We're going to cover this in 5 parts. We're going to go mastery, then productivity, then doing more, and doing it with less, and finally, self-awareness. Starting with mastery, there's a phrase I learned when I was studying Japanese long ago that goes, Chirimo tsumoreba yama to naru, which roughly translates to, even dust, if piled up, can become a mountain. And that's really the key thing to mastery. Mastery is achieved through small, incremental, directed improvements. And you've probably heard the term, 10,000 hours to master something. The real thing is just making continual incremental improvements along the way in the same direction over a long period of time. And the rest of this presentation is going to be really talking about how do we do that with software. So our second topic is productivity. So productivity is about doing more with less. It's about delivering maximum value per hour worked. Or another way to put it, we want to deliver effortless joy to our users, and we want to do it with the minimal amount of development. And this is something I think we're going to talk a lot more about in other episodes, but that effortless joy is sort of my quick way, my shorthand of saying you want to have your product have the most possible value for the customer. And in this case, the joy is the way I'm capturing that, for the least amount of their effort put into it, the effortlessness. It really should be so easy to use that it literally creates joy. Even what they're doing is compressing trash. The point is, if they get a huge amount of value for a little amount of effort, that's where the joy comes from. And that's where the immense value comes from. Also along the lines of productivity, I'm going to talk briefly about the 10x developer, and we're going to dive into this some more on other presentations as well. The 10x developer is not a myth, and this is a little link back from 2013, a study, and they found, studying a bunch of professional programmers, all with 7 years of experience, that the differential between the best and the worst programmers, all of them with 7 years of experience, it took 20 times longer for the slowest programmer to get an initial solution done. When they were debugging things, it took 25 times longer for the slowest programmer compared to the fastest programmer. Their solutions, the solutions of the best programmer, their code was 1/5 the size of the worst programmer. And the best programmer's solutions ran over 10 times faster than the worst programmer's solutions. This is the path of mastery. There really is an unbounded amount of better you can get as a software developer along all of these metrics. So our next topic is about breaking this apart into the 2 halves, doing more and then doing it with less. So I've thought a lot over the years about doing more, and my original blog way back when I started is this essenceandartifact.com. And I spent a lot of time thinking about what I consider the essential solution. And it's sort of roughly is the platonic ideal. So given what we understand of the problem domain, what is the essential solution? And we'll definitely talk about that more in other presentations as well. But the broad strokes is it's a timeless solution. It's a solution that there won't be a time in the future that there is a better solution. there might be a reframing of the problem. And then in that reframing of the problem, there becomes a new, better solution. But given the constraints of what exists now, current hardware, current software, the current people that use the software, and that's a bit of defining the essential problem. They kind of go hand in hand. You have to understand the essential problem you're trying to solve, the problem that gets to the real root of it, such that everyone who looks at this from any different angle where they start is going to end up at that essential problem. And then you create the essential solution, which is this timeless solution that will have longevity, that will last into the future, that anyone who gets here will eventually realize that this solution is the timeless solution. And really what it comes down to is separating out the artificial or the artifacts from the essential. And at the core of this is the popular phrase is Yagni, you ain't gonna need it, but I coined the term Zen, which I like a little better, which is zero extra nuts, and also like Zen because the normal connotation for Zen kind of applies too. You really want to strip everything down to just the actual essential parts that are necessary to solve this problem. The second part is that less is actually more. And I've got this picture of Steve Jobs here. This is one of his famous management product angles. And one of the phrases I like to say is you can always ship any project on time, on budget, with quality. Full stop. You just can. I'm not just being facetious. But in order to do that, you have to cut features. And that's often the hard part. People often think these are all these essential features, we've got to have them. But most of the time, you don't. You don't need most of those features to actually meaningfully make life easier for your customers. And sometimes, and this is perhaps Steve Jobs' biggest genius, removing a feature can actually make the product better. Let me say that again. Removing features often makes the product better. That is because when you put a bunch of features in, your hope is to make this product apply to all the different things someone might want to do with this product. So you're trying to get every little last use case covered of this product. You're kind of being a jack of all trades. And in doing so, you become a master of none, in that the flip side is focus on the main value point, the thing that 80% of the users are going to use 80% of the time, and make that 10x better and ignore the other 20%, which is going to, the other 20% is going to be, 95% of the complexity of your product. So instead, focus on that core value, that core thing you're actually trying to solve for the customers. Make that amazing and ignore all those other things, because although yes, customers might want to do those things, most of the time they're going to be doing that mainstream solution. And if you make that as efficient as possible, you really will be delivering the maximum value and you'll get that joyful outcome. So a little bit more of solving problems with less. Now, I've already talked about this in a previous episode a bit. I love the concept of dry, don't repeat yourself. And I am obsessive about it. Get obsessively dry. If you want to be a faster developer, learn how to dry up everything. Because what this means is, how do you solve the problem with less code? That's what dry is all about. Duplicate code equals more code, by definition. But it's a little bit more than that. Duplicate code is the bane of refactorability. So if you've got duplicate code, and again, I'll reference back to my dry episode previously, it's not just literally copy and pasted code, it is things that follow the same pattern. And my most egregious one of this is APIs, whether it's GraphQL or REST, whatever you're using. All of those platforms out there cause you to have to wire up the database in the backend, then wire up your API, then wire up your authorization and access, and then wire up your serialization, and maybe your library helps a little bit with that. And then you go to client side and you've got to wire up your deserialization, and then you've got to wire up your client side authorizations, because you really want the client to also enforce these things. And then you've got to present it on screen. In order to add just one field or one table to your app, you've got to wire up 6 different things. And it's pretty much the same pattern every time. That is non-dry code. And when you want to change something, you have to change a whole bunch of different things. If you change that field, you got to change 5-10 different code points in order to change that one field. That's what it means to be obsessively dry. Make it so that you can make any refactor by changing one file. Next step, get annoyed at repetition. And this feels a bit like dry, right? Don't repeat yourself, but it's a little bit more than that. When you are programming, if you find yourself doing the same task multiple times in a row, and if you're like, haven't I just done this before? Haven't I done this yesterday? Haven't I solved this problem before? Get really, really attentive to when you've done this before. You've done the same thing before. And it's all the little things. It's all the little things that you repeat. The computer is the ultimate tool for removing repetition from your life. Use it. And I think this is the last one on this topic. Get obsessive about minute details. And this is where it might feel a little pedantic. But the truth of the matter is, if you want to massively accelerate your development speed, you need to squeeze out every single second of inefficiency in your day. And I'm not just being obnoxious there. I mean seconds. Every little second that eats away at your actual time that you are spending trying to coax the computer to do what you want to do, instead of focusing on the high level, is this the essential problem? Is this the essential solution? And then having the computer almost effortlessly understand what you're doing. And of course, in a whole nother program, we've got to talk about GPT and code generation and all of this new stuff coming down the pipe with ML. So, syntax errors to start with. I think people really don't understand how terrible syntax errors are. So even with the best IDE you have that does your code completion, does your matching brackets, does all these things, just pay attention to your day as you go. How much time are you spent fixing syntax errors? One of the things I hate is all those little red underlines of all the errors as you're editing. If you are in the creative mode and you're creating things, you do not want to have all those distractions distracting you from the creative aspect. Those things are detracting your ability to create. And yet, it seems to be in vogue to have the compiler complain at you with maximum loudness and everywhere it can about how broken your code is as you're creating it. It's insane. I try to turn all that stuff off. But also, your choice of language impacts how much syntax errors affect you. And honestly, that's one of the key things that I designed Caffeine Script for, is to minimize syntax errors, to make a language where syntax errors are not very common. It's really easy to code without having syntax errors. Next up, waiting for the CPU is lost time. I mean, this seems kind of obvious, but I don't see very many people paying attention to this. If you are waiting for a git commit hook, my favorite pet peeve, that is burning up your time. If you are waiting for a compiler, if you're waiting for a reload, or if you're waiting for your tests to run, or if you're waiting for your CI/CD to run, or if you are just computer slow, get a faster computer. It matters a ton. There's no better investment than getting a software developer the fastest machine out there, because all of that waiting is just a multiplicative slowdown for a software developer. And it's really all the little things. Like if your editor's a little sluggish, like if you're just waiting for your editor to do code completion, or if you're waiting for your editor to pop up hover information, if you are waiting for a slow search, if your IDE takes 5 clicks to get to the next step that you're doing every time. These are all the things that eat up all your time throughout the day and have nothing to do with solving a real problem. All they are doing is solving the bad UX design, the bad performance of your system. And you as a software developer have the power to fix that. Next, also seems obvious, turn off alerts, because we need to be in flow in order to be most productive. And all these alerts just destroy flow. And I'm going to kind of work backwards. I am going to call out, turn off your phone alerts, turn off your Slack, turn off your email, turn off your reminders, and turn off your OS alerts. And I want to respect Windows developers. There's a lot of you out there. I know that a lot of people develop on Windows, but I've been forced to develop on Windows a lot lately, and it's insane how much of that OS is constantly bugging me by popping up, oh, you should check out this, or you should update that, or you should go look at this thing. And the OS just does not seem to respect my time. It seems to be doing everything it can to steal my attention away from the work I'm trying to do. It's so ironic that it's supposed to be the work OS when it seems to be the OS that's most most obsessed with making sure I don't get my work done. Not that I have beef with every OS, but tie your OS down until it can stop irritating you and distracting you and pulling you away from your work. Oh, I said turn off linting. Turn off linting. I know everybody seems to like linting. I am not one of those people. This is probably another topic for the future. I do think linting is quite literally admitting faults in the language. It's covering up things where your language is inadequate. That's what linting is. And it is there nominally to make your code better. But I've seen everyone I've worked with seems to think that no, all linting is good linting. And that is not true. Linting is like creating syntax errors for you when you didn't need one. Like it's like voluntarily stepping into having syntax errors to suck up your time. So I think in the real world, a lot of people are not going to turn off linting, but think really hard about every single linter option you're using. Is it really worth this time having it distract you out of flow all the time to work with it? Is it really making your code that much better? I like a few little things linting related, like unused variables. But again, those shouldn't be present when you're in the creative mode. When you're creating, those are all distractions that drain away your creativity. And that is the power time. That is the time when you get work done, when you get things done. It should be in the cleaning time, when you go back and you refactor and you clean up and you make it better. Then yeah, it's nice to have some sort of code IQ that can help you understand what's going on with your code. So I have a few slides like this throughout this presentation called Shane's Path. And these are some of the things that I have either used or built to help me develop faster. I certainly recommend them, obviously, but I also want to say these are what was right for me, and everybody else has to figure out what's right for them. So on this slide, I've got Neptune namespaces. These are all JavaScript tools in this case, because I've been mostly working in the JavaScript land. Caffeine script's my language, but it stands atop of JavaScript. Neptune namespaces takes your directory structure, automatically creates index files and namespace files, so that all you have to do is import the root of a directory structure with a require statement or an import statement, and it will bring in the whole structure for you in a namespace organized hierarchy. It is immensely powerful, and it reduces a huge amount of boilerplate imports and exports. That's the big thing. It eliminates all of this sort of cruft of imports and exports everywhere that normally happens in every JavaScript app out there. And it provides your code with a nice structured hierarchy of all your files, well organized, imported all together, so you can just go fetch the things you need in order to get work done. It also dries up your code, because the names of your files are part of your code. And so often, look at your code. The name of your file, often people's names of their files don't align with the way it's used in their code, or the casing of the names of the files doesn't align with what's in their code. I make sure my names of my files have the same casing structure as the code itself and have the same exact names. And Neptune namespace generates these files for me automatically, so that I don't have to duplicate the names of the files. The names of the files provide the naming themselves that then the rest of the code can import and interact with. So it actually cuts down my code also, because I only have to put it in the name of the file, and then that name is present in the rest of the code because of this auto generation. Art build configurator. I built that quite a while ago, and I've been working on a newer version, but it's basically there's a whole lot of cruft in, for example, a JavaScript package that you're building that can be basically auto-generated the same with everything. And so I've got dozens of packages that I manage, and so I needed a way to just automatically generate all that stuff for me and manage all that extra stuff for me. So the code that I'm actually editing is really the meaningful part. Art Test Bench is another one that is a little bit different and quite useful. It's a set of tools for writing tests easier. And actually, I probably should just call out Art Chained Test, I believe is what it's called. But it's part of the Art Test Bench. You can get it from there. It's probably the most powerful tool I've built, which allows you to make a sequence of tests that one test depends on the previous test succeeding. If the previous test failed, it won't go on to the next test. And what that allows you to do is anytime you've got, particularly like you're testing APIs or other asynchronous things, or even just something that is a sequence of events that any one of them could fail. It allows you to really cut down on your test size in that you just make one test for each step in the sequence, and the return value from that test becomes an input value to the next test. It works much like promises. But they're each individual tests, and it does the right thing. Like if your second test fails, then it will skip the final three. It works really well at making your tests also very descriptive, more descriptive than other systems I've seen, in that this, then this, then this, then this, and here's the sequence. Oh, it got that far and it failed. And that allows you to make each of the tests really small, because if there's a lot of setup, that's just in the previous test. And so the test that failed tells you very clearly what failed in a very small way. So it makes debugging with tests much faster. Arc chain test works with both Jest and Mocha. So cheers, it works a little. In fact, ironically, I like Jest these days. I'm using Jest most of the time, but it works better with Mocha because Jest does not have a way for you to skip tests at runtime. Come on, Jest, get with the program. There's a request out there for it. All right. All of this kind of accumulates to my big philosophy, which is write less code. It seems almost trivially simple, write less code. But here's the thing. Code is a liability. Let me say it again. Code is a liability. And this was an aha moment for me a while ago. I just about guarantee most software companies consider their code to be their asset. They consider code to be an asset. It is not. The value that code delivers to people when that code is executed, that is the asset, but the code itself is a liability. And here's why. Because the code just costs you. It is a never-ending cost, because in order to do something with that code, it takes time, and time is money. And so maintaining code is a constant cost on the business. It is a liability. So you want as little code as possible, because code is a liability. You want to minimize your liabilities. You still want all that value. You want the asset, which is the value that code gives you when it runs, but you want to minimize the liability, the size of the code. So here's my metrics. These are very hand-wavy, but I think they're a good way of thinking about it. Every line of code you write, you're going to rewrite it at least 10 times throughout the lifetime of your project. If it's a long-running project, on average, you're going to have 10 times as many edits as you have lines of code. Further, you're going to reread that line 100 times. So for every line of code you write, you're going to effectively read 100 times. So if you've got a 10,000 line program, you're going to, over the lifetime of the project, you're going to read 1,000,000 lines of code, because you're going to go back, you're going to reread, you're going to debug, you're going to have to read over there and read that. If you got multiple people in the project, even more so, because everybody's going to have to go read these lines multiple times. So every line of code has a huge multiplicative factor. Every line of code costs 100 times more than the line itself. It matters a lot to reduce your code size, because we want to write our code to be read. We're going to read our code way more than we're going to write our code. And we're going to write our code way more than just the first time we add that line to it. Think about writing your code to be read, because most of what's going to happen to your code is going to be read in its lifetime. So my path here really is Caffeine Script. And again, this is something I'll probably touch in a future episode. I haven't touched on this yet, but Caffeine Script I'm still maintaining Caffeine Script. It's inspired by CoffeeScript, but I felt like CoffeeScript got halfway to the answer, but did not get all the way there. It is a way to write JavaScript way faster. This is writing JavaScript at 3x. The modern Caffeine Script is even getting closer to about 4x more expressive than JavaScript. And TypeScript's going the opposite direction. TypeScript's even less expressive than JavaScript in terms of lines of code to meaningful value delivered. And Caffeine Script also does things like reduces your chances of having syntax errors. It's much harder to have syntax errors in Caffeine Script. And that doesn't mean, it just means that it's much easier to code things right the first time. But most of all, it reduces your code by 3x. And that is huge, because it means you got 3x less code to maintain, 3x less code to read. Whereas a program might have taken 3 or 4 pages, you can view it all on one page, which allows you to comprehend what the code does way better. I think it's hugely powerful, and I would love to talk to anyone who wants to talk more about it. Debugging. All right, so here's a key thing about debugging. 95% of bugs are trivial. They are probably a 1 or 2 line fix. But the problem is Debugging is hard because it's hard to find the bug. It's all about visibility. It's all about instrumentation. And I got this picture of a telescope here on this slide. So the trick with debugging is to get good at introspecting your code. And the biggest thing, my master's tip here, is as you're writing code, build in introspectors. One of the things I do on my projects is on all of my objects, I have ways of logging them to the console that really shows what they are, that shows them in a way that's very readable and understandable. And I find that to be immensely powerful because for debugging, I'm going to be endlessly inspecting my code, understanding what's going on. I put a lot of effort in my libraries to make them have great introspection, great ways of presenting the current state in a way that's human readable and human understandable. And all those things make debugging so much faster. Here's a few things on my path, tools I built. I built this thing called the Art DOM console, and it's just another console for JavaScript, but it does a couple things that the JavaScript console just doesn't do that makes life so much easier. One, if your string looks like a color, it'll also highlight it in color. So you can debug all of your colors and you'll see what the color is. That's hugely helpful for presentation stuff. If you have an image, which my UX stuff often has a lot of images, it'll actually render that image in the debug rather than a very crummy a representation of the object in pure text. So you can just see what the image is. And perhaps the most useful thing is if it's a promise, it'll actually log that you have a promise. And then when that promise resolves, then the logger will come back and log the results of that promise. Because so often you're logging something that has a promised result in it. And if it just tells you promise, you know nothing. That's useless, utterly useless. But usually the promise resolves milliseconds later. Like there's no hesitation. It's right there, but you've already lost it because you didn't log the promise then. So all these things make introspection so much easier. And it's set up so that I can add more and newer introspectors. Like I can make every object can define its own way of being introspected with this logger so that when it gets logged, the object itself tells the system how to log it to be most useful. And that's my artstandardlib.log does this. It actually logs to the DOM console. If you're on a Node app, it actually has a much more concise and beautiful printout that's a lot less verbose. It uses the caffeine script syntax, so it's a lot easier to read. And last is this concept of inspected objects. So Ruby has this sort of concept. I don't think it's built into language. Maybe it's built into language, but it's a standard API everybody uses, which is .inspect. Every object has a .inspect on it that you can run, which will return a inspected version of that object. Ruby has this concept built in of you're going to want to inspect your runtime objects. What I found in JavaScript, and I think this probably applies to most languages that don't already have a built-in inspect concept, is really the baseline pattern that works really well is have your inspectors return a plain object structure. So in JavaScript, I return basically a JSON structure, a structure of plain objects, plain arrays, plain numbers, plain strings. And so all of my more complex objects all implement this inspected objects function and return a simplified JSON serializable object. That in turn is super browsable with all the standard browser console log, or if you're using the Art DOM console or whatever it is, it just makes things in a really easy format for introspection. And it also is something then you could then serialize. And being serializable means that you can actually really easily use it as a tester in your tests. You can take this complicated object structure, say, get the inspected objects, and then test against that for your tests. It's just a very powerful pattern I found for introspecting code. All right, last of the 5 categories, self-awareness for software devs. The first step of self-awareness is observing. You've got to get good at observing what you're doing. You can't improve anything if you can't measure it. So here are a few things that I do for myself for observing and some particular tools that I use, but I think these are good general patterns and you can use the tools I use or not. First, tracking your workflow and doing it in an automated way. I have a tool, and there's got to be other ones out there like this, and it's called timing. It's a really terrible name for Mac, but it just logs every minute what my current foreground application is and what file I'm editing or what path I'm in. And so if I'm on the command line, it knows what path I'm in and it logs that. If I'm on a web browser, it knows what URL I'm in. If I'm in my editor, it knows exactly what file and its path that I'm in. And so among those things, it can automatically detect like what project I'm working on because all those things are in the same path. They have the same base path. And the thing is, I just turn it on and it just logs. That's it. You just start it and it just logs. That's the point, is the effortless logging. And then you can go back later and say, how did I spend my day? Where did I spend all my time? When was I productive? Where was I working on that? When was I distracted, not productive? It's really hard to do it at the end of the day if you just want to squint and wink and guess what you were doing. This lets you know exactly, and it is effortless. You just turn it on. And it has all kinds of querying ways of browsing your information, what you've done. I've been literally running my timing app for maybe 8-10 years. So I have 8 or 10 years of logging every minute of what I've done at my computer. And I use that information. I use that information to introspect and figure out how to do things better. Intentionally plan time for introspection. So logging all this information is great and all, but if you don't go back and look at it, it's not going to do much for you. There's different ways to trigger when you might want to do introspection. You certainly could do some type of reminder to do it. And so I recommend this Do app for iOS. It's my favorite reminder app. And I like to say I like it because it nags me. Specifically, you can configure exactly how you want it to nag. Like every half hour, remind me until I say I've done it. It gives you all kinds of great options for nagging or less nagging. But to me, a reminder app is useless if it doesn't actually remind. If it reminds me only once, that's a useless reminder because I'll just not remember that I got reminded. Constant note taking. This is perhaps the biggest intentional one. So you set up something automatic, as many automatic tools as you can, because those are easy and free from you. It doesn't eat any of your time. But also take notes, and take notes everywhere, all the time, anytime. Certainly. One of the things I like to do, for example, for taking notes is anytime I'm using some tool and I'm frustrated by when it does something that I don't think it should do, what I'll do is I will take that tool's name and then I will append the word shortcomings, which is my little keyword to search for, and I'll make a note. I'll say that tool space shortcomings, make a note, and I'll note what the failure was. And then I'll go about my business. One, it lets me get it out of my brain, which lets me alleviate the frustration. But more interestingly, I can then go back later, search for that tool plus shortcomings. I can see how often I've logged that. I can see all of them together and I can start to see patterns. I can see, oh, this tool is eating up a significant amount of time because it keeps annoying me on the same way. And then which might say I should use a new tool. It might say I should use this tool in a different way. Or it might suggest you should make your own replacement. That is my story of how CaffeineScript came to be. I started doing this when I was using CoffeeScript, all the things I was annoyed with CoffeeScript. Lo and behold, at some point I had 200 plus notes like this. And at that point, I started to see really strong patterns like, oh, here are the capabilities that this language needs to have in order to actually be superior to CoffeeScript. And it was actually really clear how CaffeineScript needed to come together at that point. And it made, once I got to building that tool, so much easier, because the hardest part of any tool is knowing what to build and knowing that it's the right thing. Constant note-taking is the way to get there. Next thing. Check in your code obsessively with Git. This is another thing I don't see a lot of people doing. I recommend checking in with Git 6 to 12 times a day, like several times an hour. What that does is that creates several benefits. One, and this is what I'm arguing for here, it creates a work log, like an intentional logging, like I reached this point, I did these things, you put a little bit of comment on it, it knows what files you changed, you've got beautiful diffs because it's Git. And you have this work log of what you did at every step of the way to get to the end of the day. And when you want to go back and reflect on it, you can browse through those commits, the commits you did in the last week. You can browse through them, see what you did, see how you spent your time because they're all timestamped. It is a phenomenally powerful self-reflection tool. There are other benefits to checking in often. And the other big one really is they're basically like save games. They're checkpoints along your way to a solution. And if you do those commits each time you make a little bit of measurable progress, one more test passes or whatever it is. And then if you get to the point where you break something, you don't know what you broke, you can roll back to that last commit, which if you're doing it often is only a few changes back. That's one of the huge reasons that you should commit often. And since committing often is so critically important in my opinion, you should never have git commit hooks. because that forces you to commit less often, which is a terrible idea. All right, getting inspired. So you're doing observing, you're doing reflection, you're doing all this logging stuff, but now you need to take all that sort of raw information and you need to get inspired and sort of get you motivated to do something positive with all the information. So here's a few sources of getting inspired, but this is very personal and there's a million ways to slice this. Go explore well-written code. Go out in the world. There's so much open source out there. Find stuff that you think is really well-written and inspires you. Just browse other people's code. That tends to be a good thing for me. Learn new languages. I think it's so critical to learn new languages, new platforms. When you just know one language and one platform, your knowledge is so narrow that you have very little perspective. And even if your platform is great and you love your platform and you go learn 2 other languages and 2 other platforms and you come back to your original language and platform and say, I still love this, you will be already a 2 to 3 times better programmer when you come back, because you will be able to have now seen yours from the outside. You'll know why it's good. So you'll know how to leverage its strengths even better. I also recommend, and this is not as common a recommendation, that you write a language. I really think it's important for every single software developer to write a programming language, because if you don't understand how the tool that you're using, your most important tool, is made, and more importantly, the choices behind the person who designed it, why they made the choices that they made, if you don't have any concept of that, you are again lacking the perspective to leverage your tool well. So writing a language, even just a toy language, in fact, I argue you should just write a toy language. I don't think you should try to, really write the next JavaScript, just because practically speaking, it's not going to happen. It's kind of ridiculous that I wrote caffeine script, but that's my passion. But I think that you should write a little toy language. And of course, the last episode of Caffeine Script showed you how to write a toy language in 30 minutes. It's really is that easy. Then play around with it. Play around with the language choices. What makes the languages work well in terms of different trade-offs? It will really illuminate your path in terms of understanding how to leverage your language of choice all the better. Another fun one I like to do, and I like to do this also with just general product design when I'm trying to solve problems for users, is go to a newsstand and in person. I think it's really important to be there in person. And hopefully it's a newsstand with the biggest amount of magazines everywhere. And what you're going to see is a huge amount of beautifully designed information presentation. And just take the first 5 magazines that grab your eye and grab them. I would recommend buy them, but even if you just flip through them and just take the inspiration. There's so much graphic design effort that goes into these things, and there's so much stuff that you would just not have known about because you didn't go and get inspired by them. I find going to the newsstand super good way to jog my brain if there's nothing else that I can get to jog my brain. All right, so now we got all this. Now we need to review, and I guess I'm arguing here also for another way of tracking things with journaling. And really journaling I use journaling as a reflexive, right? So I'm not like logging in my journal all the things that I've done. I've got other tools for logging all the things I've done. I use journaling to write down my high-level goals, and anything that pops in my head after I've written down my high-level goals, I jot that down. So I have this sort of continual processing around these high-level goals. I also like to periodically go back and organize my notes. Like I said, I've now got 200 CoffeeScript shortcomings notes. Go back and re-edit them. And what I do suggest when you're organizing your notes is don't actually change the old notes. Those are historical record. Copy all those notes. So if you got like 5 notes that are all kind of on the same thing, copy them all into a new note, make that new note beautiful and organized, and maybe reference the old notes. But use it as a chance to keep a historical record, but also re-summarize, recollapse, bring your thoughts together, periodically organize your notes. And then finally, take action. So now you've done this, you've observed, you've got inspired, you've got tons of information. Now you know what needs to happen. You've got 10 or 100 notes on a problem. You know the solution. Then it's time to do it. It is time to use the most powerful tool in the universe, software development, and solve that problem. Software development is a superhuman power. It allows us to do things that a human without a computer cannot do. So take action. I think way more people should be writing packages, and way more people should be writing languages, and way more people should be creating better tools, even if it's just for your own team, to accelerate your own team. In fact, that's probably what it will be for, and that's okay. These tools are powerful, and they are not actually that hard to do if you follow these paths. And this is what can help accelerate your development speed. So that's a lot of the self-awareness around software development specifically, but in general, all the tools of self-awareness that you see from gurus outside of the software sphere are also going to help you have better self-awareness in software specifically. We want to maximize our time in flow with software development. And so these other things in our lives matter. Your health, your nutrition, your exercise, your healthy environment, your self-care, doing mind quieting practices like yoga or meditation or walking. I've been finally getting a meditation routine in this year where I'm doing it every day, and it's actually starting to really help me drain away my noisy thoughts and to make space for the novel thoughts, the inspirational thoughts. In fact, it's one of my measurements of, am I done meditating for the day? Have I had some original thoughts? And they won't always necessarily be on the software of the day. They'll be on other random things. It's amazing how powerful it is, and it just takes a daily practice. And stimulate your senses with the world. I mean, I mentioned magazines a moment ago, but really anything it is. Go out and engage the world. Find beautiful places, find beautiful food, have conversation with beautiful people. And by beautiful, I mean that internal sense of beautiful people who are going to show up and engage and be authentic and be their best selves. And they're going to do them, and they say, you do you. And that's what's going to inspire you to continue down this path. So in conclusion, the path of the software master in 5 steps. First is just understanding mastery. All of the rest of this is going to not quite click for you yet if you've not gone far enough down the software development path to the point where you can see, oh, this is an infinite path where I can get infinitely better. I understand this path well enough now to see how I can keep getting better and better and better and better. Now I get it. Then you're going to start focusing on productivity. How can I get things done faster? How can I deliver more value with less effort? And the key trick, as always with mastery, is self-awareness. You have to have this feedback cycle to bring awareness to what parts of your routine are not serving, so you can move past them and open up more time and space to do things that are serving and develop software faster. Thank you once again for spending your valuable time with me. And remember, all problems are solvable with enough knowledge.